Today we're going to talk about multiplying and dividing rational expressions. When we multiply a rational expression, we're going to simplify or factor each rational individually and cancel out matches. We're going to cancel out matches on the diagonals. We know anything in the numerator can cancel with anything in the denominator. And then we multiply straight across. For number one, these are all monomials. That means they each have one term. So we can either go ahead and simplify, if possible, numerators and denominators, or we can multiply straight across and then simplify. There's two different ways to go about it, depending on how your brain works best. So if we go ahead and just multiply, because they're monomials, 3 times 12 is 36. X times x squared, you add exponents, so we're going to get x cubed, y, z, divided by 5 times 6 is 30, and then yz squared. We're going to simplify the numerators and denominators, so 36 divided by 30, that's going to simplify to 6/5. X cubed stays on top because there's no x's on the bottom. Y divided by y, we subtract exponents, so that gives us 0. The y's become 1. And then z and z squared, we subtract 2 minus 1 is 1, and it goes wherever the bigger exponent is. So we get 6x cubed being divided by 5z. For 2, we have a binomial being divided by a binomial, and then another binomial divided by a binomial. So the first thing we're going to do is realize, oh yeah, these are groups. We're going to factor first. So when I factor the numerator for the top left, it has a GCF of 3x. We're left with x minus 2. The denominator on the left side has a GCF of 3y. So we're going to be left with y plus 2. And then times, we have a GCF of 2 for the right numerator and a GCF of 2 for the right denominator. We now look for groups. Any group up top can simplify with any group in the denominator. So x minus 2 and x minus 2 match. Y plus 2 and y plus 2 match. My 2's match and my 3's match. We're left with just x divided by y. For problem 3, I've got a binomial being divided by a trinomial and a trinomial being divided by a binomial. I'm going to try and factor each of my groups. Right now, none of my groups match exactly. For the top left, GCF of 2. My bottom trinomial is going to be x plus 2, x minus 1. Got x plus 3 for the bottom. There's no GCF there. And then up top, it's a trinomial. So 5x and x plus 2 plus 1, that'd be 10 and 11. Now, in any group up top can simplify with any group on bottom. X plus 3's match. X plus 2 matches. We're going to be left with 2, 5x plus 1 divided by x minus 1. I don't have any other groups that match exactly. Therefore, that is my final answer. Do not multiply right now. You can. But when we start to solve equations or graphs, it's going to be really important not to leave this in factored form and not simplify it per se. For problem number 4, I've got a binomial divided by a binomial and another binomial divided by a binomial. So put your parentheses around to show your groups. Your groups must match exactly. They do not. I'm going to try and factor each group. For the numerator on the left, we have 3a. We have a minus 8. The bottom one has no GCF. On the right side, I have a GCF of 6 for the numerator. So I'll have 6a plus 4. And in the denominator on the right side, I have a GCF of 3a. So I'll have a plus 4. We're going to look for any group up top and any group in the bottom. They can simplify. So a minus 8, a minus 8, a plus 4, 3a, 3a. My answer is going to be 6. When we're dividing by a fraction, means that you must multiply by the reciprocal instead. AKA, we're going to flip the second and multiply. Please do that first. So before we start factoring or doing anything crazy, go ahead and just flip our second and change it to multiplication. So for problem 1, we have 3x plus 21 divided by 3x squared minus 9x times x squared minus 10x plus 21 divided by x squared minus 49. I'm going to go ahead and factor what I can factor. On the left numerator, I have a GCF of 3. The left denominator, I have a GCF of 3x. Right numerator is a trinomial. X minus 7, x minus 3. And denominator is going to be difference of squares. We can cross out any groups that match between the top and the bottom. So x minus 7, x plus 7, x minus 3, and the 3's. Up top, I don't have anything. Remember when we simplify though, it really becomes 1. So anything divided by itself is 1. I have a pretend 1 up there. I'm going to have to write it this time because I have an x left in the denominator. Our answer is just 1 divided by x. For problem 2, again, my first step is to flip the second and change it to multiplication. 2x squared minus 5x minus 3 divided by x plus 5 times x squared plus 4x minus 5 divided by x squared plus x minus 12. Trinomial, so we're going to try and factor that. 2x, x minus 3 plus 1, negative 6, negative 5. X plus 5 cannot factor, it's prime. We're going to have x plus 5, x minus 1 for my trinomial of x squared plus 4x minus 5. And then x plus 4, x minus 3 for the trinomial of x squared plus x minus 12. I'm going to simplify. So anything in the numerator can simplify with anything in the denominator. X plus 5 matches. X minus 3 matches. And then I write down what's left. 2x plus 1, x minus 1 over x plus 4. Again, leave it in factored form. That's going to be more useful later on. For problem 3, we have a monomial being divided by another monomial. We're going to kind of take it the same way. The first thing I would do is I would do the exponent first, because that is the exponent for the whole problem. So that means everything in here is being cubed. So we have 2 cubed, which is 8x cubed being divided by y cubed. After I take care of the exponent, I'm going to go ahead and flip my second and change it to multiplication. And then because it's just a monomial times a monomial, I'm going to multiply straight across first and then see what I can simplify. So 7x y cubed, we'll get 8x cubed y squared. 7 divided by 8 does not simplify. With the x's, we subtract exponents. 3 minus 1 is 2. It goes wherever the bigger exponent is. With the y's, again, we subtract exponents. 3 minus 2 is 1. And it goes wherever the y is. So 7y divided by x, 8x squared. Sorry about the phone there. For number 4, this is a crazy looking problem. It just means, remember, fractions just mean division. So it means I've got one fraction and I'm being divided by another fraction. I would always suggest rewriting this how we're used to seeing it. It helps brains not explode as much. So we know we're dividing two fractions. So we're going to flip our second and multiply. That's the first step I would take. After I do that, I'm going to factor everything possible because I have binomials and a trinomial. So I know they're all groups. And I know I have to get my groups to match if possible. I have a difference of squares. So 2x minus 5, 2x plus 5. I have a GCF of 3 in the denominator. 2x minus 5. GCF of x for the numerator on the right side. X plus 2. And then trinomial in the denominator on the right side. So 2x, x plus 2 plus 5. That gives me 4 and 5, which is 9. Now anything up top can simplify with any matching group in the denominator. 2x minus 5, 2x plus 5, x plus 2, and I'm going to be left with x divided by 3. For my last problem, I have 3x minus 6 being divided by 2 minus x and x plus 3. And then that whole thing is being divided by 3. So whenever you see something that is not already in fraction form, there's always a pretend 1 underneath. Because when you divide by 1, it doesn't change it. First thing we're going to do is flip the second and change it to multiplication. And they were really nice and already factored the bottom for me. Now I just have to factor the top. So we're going to get a GCF of 3. The only difference between these two groups is the minus sign. This is a positive x, negative 2, positive 2. To flip all the signs, we're going to choose one, either numerator or denominator, and factor out a negative 1. It doesn't matter which. I'm going to do in the denominator. I like my x's to be positive and in front. When I do that, I'm going to get denominator. I think my spelling's bad there, but I tried. So I'm going to factor our negative 1 there. So I'm going to have negative 1, and then that's going to make that negative 2. That's going to make that positive x. Positive divided by negative is negative. Negative divided by negative is positive. X minus 2s are the same. The 3's are the same. We're going to be left with 1 divided by negative x plus 3. And you can leave it exactly like that.